Good day. My name is Melvin Chongwe, and I'm here to present my research project on a proposed traffic monitoring system under the supervision of Professor Sigrid Everett, Professor Ian Sanders, and Dr. Olapere Okupeyecho. The presentation covers the following sections of my research project. The first one, the problem statement, the aim, the proposed research questions, the methodology, results and discussion, and conclusion. Various methods and techniques have been used to address the issue of traffic congestion, but none have been proven to be effective in reducing traffic congestion. The most recent and widely used is the online one. The most popular applications are Apple Maps, Waze, Google Maps, and others, where users can notify other users in that area. Thus, the road is congested, and these applications receive information indirect from users using location to determine if there is traffic congestion or not. However, user-based traffic update applications make it difficult for motorists in a region if users are not updating other users nearby on the applications for different reasons, or when the application cannot obtain information from users' devices due to different reasons, such as not having internet connections, which could cause drivers to be unaware and take any route that could lead to congestion. In addition, these systems report when there is already a heavy traffic jam, which is not really useful to users. Thus, establishing a system that does not require a user input will benefit all motorists by installing low-cost cameras in heavily used intersections and configuring these cameras to determine traffic flow and detect congestion. In this presentation, I will be discussing the real-time traffic monitoring system I proposed that will monitor traffic flow at an intersection and notify people if there's congestion so that they can take alternative routes. There are two research questions that were proposed prior to designing the system. The first one focuses on how will the system determine the number of vehicles arriving at an intersection per unit time, which is the rate, is significantly greater than the number of vehicles leaving, implying that congestion is starting to happen. The second one focuses on the effectiveness of the system, how effective this system will be by using low-cost camera to detect and classify traffic congestion at an intersection. The methodology used to come up with an optimal traffic monitoring system consists of 4 sections. The first one is data collection and preparation. The second one is vehicle detection. The third one is vehicle tracking and counting. The last one is traffic congestion detection and classification. For data collection and preparation, the data sets used in this study was captured using a camera at different times of the day in Braamfontein, Johannesburg, near the Wits Arts Museum. The study uses a pre-trained weights neural networks model architecture and class names from a study conducted by the Cornell University. The videos were processed to focus only on approaching vehicles by filtering out parked vehicles. Furthermore, the system uses a 45-second duration to determine traffic flow at an intersection. The traffic lights remain green for 30 seconds. However, the system will not be robust if the captured videos were processed to be 30 seconds, since it will not count vehicles that arrived after the traffic light has gone red. As a result, the videos were trimmed to 45-second segments to determine the number of vehicles arriving after the traffic light turned red in order to detect the traffic congestion if vehicles arrive non-stop after the traffic signal turned red. The proposed systems uses the YOLO Vision Tree network, which contains 24 convolutional neural network. The algorithm is used to detect, track, and count vehicles on scene. The information obtained from the previous phases, like detecting, counting, and tracking vehicles is used to calculate and compare the rates at which the vehicles arrive and depart from an intersection over a given period. Iteration of data vehicles is used to determine whether the road is congested or not by calculating the traffic flow using 45 seconds and 30 cars, whether and compare these threshold to the obtained traffic rate for a specific video. Results and discussion. As can be seen from the table, the system is capable of detecting, tracking, and counting vehicles on scene. Though the results show some errors in which the system detects and counts other vehicles more than once due to the lack of non-stationary camera and reflections on building glasses. The largest error visible in these results is in testing one, is that the vehicles were overlapping by moving closer to one another and not being able to be detected and counted only once. And then when the following distance increased, the vehicles were then detected again and counted again, while they were also detected and counted before they overlapped. Here's an illustration of the system performing the detection and tracking and counting. Using the results from the previous slides, the classification was performed to determine whether the intersection is congested or not. Here are the results. Overall, the low-cost camera implementation is robust, ignoring the factors that contribute to the system inaccuracy, which were discussed previously, which is the camera not being stationary and the reflection on glasses. How can we improve this system? We can improve the system by filtering our glasses, also like as we did with the parked vehicles, and configuring a more stationary camera for capturing the videos. Conclusion are users are therefore updated more regular and efficiently than when the system is dependent on users. Their work contributes to the field of computer vision and traffic analysis since it integrates the two. Future work could expand the stack by extending the system to include an API for communicating with drivers using the most used communications method. Also, they could implement the system using images at an intersection to monitor traffic congestion by handling the drawbacks of using images in traffic monitoring. Thank you.